All right, so example 11. In example 11, we're asked if f of x is equal to 2x plus 2 plus 3 is 1 to 1. Well, let's just use the two approaches that we have. Let's make f of a be equal to f of b. Then f of a is a squared plus 2a plus 3. Let's make this equal to f of b, which is b squared plus 2b plus 3. And then let us find out what a is equal to in relation to b. All right, so I think this is how it was done. A squared minus b squared plus 2a minus 2b plus 3 minus 3 would be equal to 0. So then we have what? A squared minus b squared plus 2a minus 2b is equal to 0. Because 3 minus 3 is 0. We can factorize a squared minus b squared. That's the difference of 2 squared. So we have a minus b multiplied by a plus b, plus we can factorize 2a minus 2b to get 2 into a minus b, and this is equal to 0. Now we can factorize the entire expression on the left because a minus b is common. So let's put a minus b outside of a pair of brackets. And a minus b into a minus b, a plus b is a plus b. And a minus b into 2 times a minus b is positive 2. And this is equal to 0. So now I'm multiplying two expressions and I'm getting 0. So it's either the first that is equal to 0 or the second that is equal to 0. Therefore, from the left side, a is equal to b, or on the right side, a is equal to minus b plus 2. Sorry, minus b minus 2. So let's make our statement now. Now when f of a is equal to f of b, a is not always equal to b. Therefore, f of x is equal to x squared plus 2x plus 3 is not injective. Now, for the alternative approach, so we have f of x is equal to 2x squared plus 2 plus 2x plus 3. And we're asked is that function 1 to 1. Now, the alternative approach is to draw a sketch of the graph of y is equal to f of x. So in other words, we're being asked to draw a sketch of a quadratic function. There are some things you need to remember, that a positive x squared graph. So a positive x squared graph, that means that the coefficient of x squared is positive, is a smile, and that the negative x squared graph is a frown. So that's one thing to remember. Now, in our case, we have a positive x squared graph, therefore we have a smile. And if we have a smile, we will have a minimum turning point. We need to know this minimum turning point, what this minimum turning point is, in order to draw a sketch. Now, in order to determine the minimum turning point, we need to write the function. We need to complete the square for the function. Now, completing the square means to write f of x is equal to ax squared plus bx plus c in the form a into x plus h square plus k. That is what completing the square means. Now, once we have this, once we have written the function in this form, we need the turning point. Now, the turning point is either the minimum turning point in the case, as in the case of a smile, or a maximum turning point as in the case of the frown. Now, the turning point is always minus hk. Now, you did learn how to do completing the square in CSEC, and it was also rehearsed in ADMATH. But there's a formula approach to it. You could find h. H is equal to b over 2a. Now, in our case, a is equal to 1. So a is the x squared coefficient. B is equal to 2. B is the x coefficient. And c is equal to 3. C is the constant term. So we can find h. So h would be equal to b, which is 2, over 2 times a, which is 1. So h is equal to 2 divided by 2, which is 1. So remember, your turning point is minus hk. Now, minus h is therefore minus 1. Now, we can find k because k would be equal to f of minus h. In other words, k is equal to f of minus 1. So k would be minus 1 squared plus 2 times minus 1 plus 3. So minus hk. Why do I feel like I made a mistake somewhere? But let's just continue. This is 1 minus 2 plus 3. This looks as if it is what, 4? This looks as if it is what, 2? So this is telling me that minus 1, 2 is my turning point. I'm feeling like I made an error somewhere, so I'm checking. H is equal to b over 2a. B is 2. H is equal to 1. Minus h would be minus 1. And k would be f of minus h. All right, it seems fine. So now I can do a sketch of this graph. To do a proper sketch, I would need the intercepts, the x-intercepts, but we're not going to get into that now. So let me try and do my sketch. I'm drawing my vertical axis. The y-axis, drawing my horizontal axis. Which is the x-axis. 0, 1, 2, 3, 4, 5, 6, 7, 8. -1, -2. -3. Now, -1, 2 is my turning point. I'll put it somewhere around there. And 3 is the y-intercept. My graph could look something like this. Remember, it's a parabola. It's a smile because it's a positive x-square graph. -1, 2 is the minimum turning point. This is the graph of y is equal to, a sketch of the graph of y is equal to x squared plus 2x plus 3. All right, so we have drawn our sketch. Now, I'm going to draw my horizontal line. So I draw my horizontal line, and it is clear that I've just drawn a line parallel to the x-axis that does not cut the graph. Remember, for f of x to be 1-to-1, or for f of x to be injective, every horizontal line, or every line drawn parallel to the x-axis, must cut the graph at most once. So this line didn't cut the graph at all. Let's draw another horizontal line, or another line parallel to the x-axis. Well, notice this graph cuts, that line, cuts the graph what? Twice. So by definition, this function is not 1-to-1. For a function to be 1-to-1, when you draw a graph of the function, every horizontal line that can be drawn through the graph must cut the graph at most once. If you can draw a horizontal line that cuts the graph more than once, or a horizontal line that doesn't cut the graph at all, the function is not 1-to-1. Now, let's make a comment. Since a horizontal line, or let's use the proper terminology, since there are lines drawn parallel to the x-axis, that can cut the graph more than once, f of x is equal to x squared plus 2x plus 3 is not injective.